Hi everyone, welcome back to the learning pathway about on-device object detection. Object detection is a computer vision task that detects what objects are in an image and where they are located. In this video, I'll show you how to train a custom object detection model and deploy it to a mobile app by using TensorFlow Lite. Earlier in this learning pathway, I showed you how easy it is to add a pre-trained object detection model to your mobile app. Pre-trained models are usually trained on general datasets, so they can recognize general objects. For example, in this image, a general model can recognize that there's food in the image. However, in many cases, you may find that you need a model that can recognize specific objects, such as the tomatoes or cheese in this food image. That's when you will need to train and deploy a custom model. There are 3 steps to do so. First, collect your training images and label them. Second, train a custom model using TensorFlow Lite Model Maker. This is a Python library that allows you to train machine learning models in just a few lines of code. There's no machine learning expertise required. And finally, deploy the custom model to your mobile app using TensorFlow Lite Task Library. This is a library that allows integrating TensorFlow Lite machine learning models to mobile apps in just a few lines of code. The first step, collecting and labeling your training images, is probably the most tiring step of the whole process. You need to collect the training images that contain the objects that you want to detect. In general, the more images you collect, the better model you can train. However, you can start small with a few dozen images for each type of object that you want to detect. In each image, you will need to draw a bounding box around each object and label it. In this image, for example, I labeled 4 objects and indicated that all of them are tomatoes. There are many tools that you can use for data labeling. Label IMZs is a popular open source app for data labeling. If you don't have your favorite data labeling app yet, you can check it out. Or if you prefer a web-based tool, check out MakeSense, which is also an open source tool. To make it simple for you to learn how to train a custom object detection model, we already prepare a dataset that you can use right away. This dataset contains about 100 of salad images, and there are 5 different labels: baked goods, salad, cheese, seafood, and tomatoes. Here are some example images from the dataset. The dataset contains about 100 of images and a CSV file with the labels and the bounding boxes. Each row of the CSV files represents an object in an image. The first column is data type. Train means the object is used to train the model. Validate objects are used to decide when to stop training to avoid overfitting. Test objects are not used during the model training. They are used to measure how well the model can generalize and recognize objects that it has never seen before. The following URI is the path where the image locates. We store the training dataset on Google Cloud Storage, but you can also use files from your local machine. This is the label of the object. And this is where the object is located in the training image. We only need to specify the upper left corner and the lower right corner of the bounding box. Now let's start step 2, train a custom model using this dataset. We'll use Model Maker, which is a Python library that makes it very easy to train models for common machine learning tasks. Instead of having to write a lot of code to train a model, you can do it in just 4 lines with Model Maker. Now let's go to Colab. Google Colab is an online tool from Google that gives you free access to computing resources to train machine learning models. Make sure that you have enabled GPU because it will significantly speed up your model training. You start with installing Model Maker, and then import the necessary packages. Then you can proceed to train the model. You need to choose a model architecture. Model Maker supports TFLite, which is a family of state-of-the-art object detection models optimized for mobile devices. There are 5 model variants. On one side, the Lite 0 model is small, fast, but less accurate. And on the other side, the Lite 4 model is the most accurate one in the model family, but it's also bigger and slower. Here's a graph that compares the model size, inference speed, and model accuracy. You can run several experiments with different model architectures and choose the one that is most suitable for your use case. In this demo, we'll use the middle one, Lite 2. Next, let's load the dataset. This is the salad dataset that I showed to you earlier. It's on Google Cloud Storage, but you can also use a file on your local computer. Model Maker automatically splits the dataset into training, validation, and test dataset for you based on the value you have specified in the CSV file. Then you can start the model training. It will take about 30 minutes to complete. Then we use the test data to see how well the model performs with images that it has never seen before. In this case, it shows an average precision of 40% across the classes, which is quite good for a mobile object detector. Model Maker uses TensorFlow under the hood to train the model for you. So the next step is to export the model to the TensorFlow Lite format so that we can deploy it to a mobile app. And finally, you can test the TensorFlow Lite model accuracy using the same test dataset. The TensorFlow Lite model average precision is 37%, which is a bit lower than the original TensorFlow model. There are several reasons for this drop. One of them is that we use quantization to shrink the model size by 4 times as a trade-off of reduced accuracy. If you want to retain the accuracy at the expense of a larger model, you can also choose to turn off quantization when exporting the model. Okay, now you already have the custom model. Let's download it and add it to the mobile app. Go to the Files tab on the left sidebar of Colab. Right-click on the TensorFlow Lite file and choose Download. It will take a few seconds to download the TensorFlow Lite file to your local computer. The final step will be integrating this model into your mobile app. We'll use TensorFlow Lite Task Library, which allows you to integrate TensorFlow Lite models into your mobile app in just a few lines of code. If you have used TensorFlow Lite before the Task Library release, you probably had to write a lot of code to integrate a TensorFlow Lite model into a mobile app. However, with the Task Library, this turns into just 3 lines of code. Let's switch to the Android Studio to integrate the model into your mobile app. Adding a TensorFlow Lite object detection model to a mobile app is very similar to adding the MLKit API that I have seen earlier in this learning pathway. The only difference is that it would use TensorFlow Lite Task Library instead of MLKit for this integration. You'll find that many of the steps I will show you now to be very similar to the MLKit video. You can find a link to download the starter app from GitHub in the code lab following this video. The starter app already has some UI boilerplate code. You can select one of the preset images and it will show up in the larger view. Or you can also take a photo with your phone camera. Let's start by adding the object detection model that you have trained earlier to the app asset folder. Please name it model.tflite. Then add the TensorFlow Lite Task Library to the app dependency. Go to the build.gradle file and add this line. Then next, go to the main activity and find this method. The starter app is implemented so that whenever you pick an image, either by taking a photo using the camera app or selecting one of the preset images, this method will be called. Let's add the object detection code to this method. There are only 3 steps to use TensorFlow Lite Task Library. First, you need to create a tensor image from the image that the user has selected. Next, you need to create an object detector. Here you can specify a few options. You can make the model detect maximum 5 objects in the image. It will only keep the objects that have the highest confidence score. You can also set the score threshold so that the model will discard all detection results that have less than 50% confidence. And here how you specify the model that you copied to the app earlier. Then we feed the input image to the detector and print the detection result to logcat. Let's take a closer look at the code that prints the detection result. You can see that the object detection API returns a list of detection, each representing an object that it found in the input image. In each detected object, there's a bounding box or rectangle showing where the object is located in the input image. Let's run the app and see the detection result in logcat. You can see that the model can detect cheese and tomatoes in the image. Next, let's visualize the detection results by drawing them on top of the input image. The starter app already has a convenient visualization method. You can call draw detection result with a list of bounding boxes and text. Then you will see them show up on top of the input image. Then it will get back the image like this. Next, let's replace our logcat print with this visualization method. This chunk of code loops through the detected object list, extract the top label of each object, its confidence score, together with its bounding box, and creates a data object for visualization. Then we call the draw detection result method to draw them on the original image. And finally, we show the image on the screen. Now, you can rerun the app and see the visualization of the detection results. One important thing that you need to keep in mind is that TensorFlow Lite models run synchronously in the same thread with its caller. Because the model can take quite some time to run, we need to run the TensorFlow Lite code on a dedicated background thread to avoid blocking the app UI. You can see that we call the run object detection method, which contains the TensorFlow Lite code, using the default dispatcher to run it on a background thread. So that's all the steps needed to train and integrate a custom TensorFlow Lite model into a mobile app. You can go to the code lab following this video in this learning pathway to download the source code and go through the steps I have just shown you. I hope that you found this video and the learning pathway useful. Thank you for watching.